So English is, hello, my name is Tomer. I'm the CEO of Devops. I'm the founder. Asaf here will do the demo. He's also one of the founders. Before we get started with, with ELK and trying to help you build your own ELK and some tips, something we have learned in the past. Few questions. So, is anyone here running on AWS? Is anyone doing kite surfing, windsurfing? Some? What are you doing?
We do windsurfing and sailing.
Good. Anyone else?
This is the road meetup.
What's the most important thing about windsurfing? Right? What do you look for?
The wind.
The wind. So, ELK, what is it really good for? Why did I start this company? Is because I'm a kite surfer. I love kite surfing. When you're doing things related to the ocean, you're looking for the wind. And the biggest problem that we have right now is our office is right in the Tel Aviv port, right across the beach, so we can see the sea from the office. And when there is wind, every surfer knows that it's the worst thing that you're in the office and you want to go kite surfing. But the hardest problem is to predict the wind. So you do all this, tons of websites to predict the wind, the forecast. We, as a kite surfer, need to understand when should I go to kite surf. And this is why I built a system based on ELK to help me decide when wind will instruct and when should I go kite surfing. What did I actually do? So what you see right now is this is the ELK platform. It's actually a sub-version of ELK. It's based on the original ELK, but it's something that we are adding as part of Log.io. We're adding more functionality. So you'll recognize, some of you will recognize this dashboard as Kibana 4. What we've done is we've collected wind matrix from wind stations across the country. And these are sent as logs into Log.io. And we've created dashboards and used our algorithms to predict when would it be a good time to kite surf. Because it's not just like in Devops, right? It's not just one thing that clicks. Oh, I see these error logs. Usually, life is more complicated. Like you see an error log in here, and you see a spike in the CPU, and you see maybe a customer complaining. So you see multiple makers, multiple signs, parameters that are indicating, hey, you know what? This is not normal. This is something is happening. Again, with the wind, you will see some wind in Bat Yam, and you will see some wind in Kisaria, and you will see some wind in here, but only when you see a set of parameters can you predict that the wind will be strong enough that by the time you go to the beach, you will still have wind to kite. We did a cross location, and we're using our algorithm that we'll go into in a few minutes on how to predict when exactly will be a good time to kite surf. And the most important thing about the wind is I'm not going to log into the console every day and refresh every 10 minutes. Is there wind? Maybe now I need something proactive to give me a call and tell me, Tomer, it's windy, go kite surfing. And now, since we just launched this, it's just a small thing for us, right? We have multiple users signing up to get alerts from the system. And I think there's a lot of correlation between wind analytics and log analytics and machine-generated data analytics. The same, you want to get alerts, you want to be able to analyze that data, you want to be able to predict in the end of the day when you will have a problem or easily discover it. What do we do? So Log.io, we're a log analytic company. We are doing two main things. One is we're doing ELK as a service. We call it ELK++. We're basically taking the open source solution of ELK and we're running it in the cloud as a service, so you can send us 1 gigabyte of data a day, you can send us 500 gigabytes of data a day. The service is fully elastic, it's highly available, it's secure. And to be able to predict the wind, right, we need alerts, we need role-based access so other people can access it. So we basically took the open source and made it like a bulletproof solution that runs in the cloud. What we will do in this session is we will show you exactly what we did in the architecture. So if you want to build it on your own, please do. We will also show you a list of tips that we have learned along the way, how you build a system. Even the smallest cluster that we have is almost 100 servers in size. So how do you build it? How do you monitor? this kind of servers, this kind of scale in Amazon, it's still not a huge one. We're just finishing our beta, so it's going to triple in the coming month in terms of size. And we are using, surprisingly, ELK itself to monitor ELK. So it's something which is really ingrained in what we do. So this is the plan that we're going to speak about. Yeah, on top of that, the reason we really founded the company is not to do ELK service. ELK for us is a means to an end. For people who, like Asaf and myself, who have worked with, as DevOps, as engineers, as founders of different companies, we've been using Splunk and other tools for many years. We still realize that even when you have ELK working, the biggest challenge still is in front of you. I have tons of logs. What do I actually look for, right? I can ask a question, I can run a query and say, tell me all the exceptions that happen, on this new version, which didn't happen on the previous. I can ask a sophisticated question, and ELK or Splunk or whatever product you're using will give you amazing answers. This is something you can do, but to really identify the question you should be asking, this is the hardest problem. And this is the reason we founded Dogs.io. We founded the company so we would be able to pinpoint the question you should be asking your data, because we analyze your data and we analyze all the people that are using us, and we analyze not only their data, but we analyze how they interact with machine-generated data. Excuse me. So, in a nutshell, how the way our algorithm is working, it's basically analyzing user behavior on data, and that can be through our system, that can be on the web. We collect millions and millions of matrix about how people search for data, and we apply this intelligence into machine-generated data. So, Saf will show you a demo in a few minutes, and in the demo, you see the system automatically detects logs that other people thought are very, very interesting and acted upon these logs. And we actually correlate and analyze this kind of information through machine learning, which produces these insights. This is how we call it. So this was 5 minutes about us, about what we do, and now we're not going to speak about anymore. We're going to speak about ELK, the solution, and how we have used it and how we solve the problems. Any questions so far? So, just to give you a brief introduction to ELK. ELK is a web support. Saf, can you explain what ELK is until I think?
Yeah. So ELK is a combination of Elasticsearch, Log Session, Kibana, and so Log Session is like the kind of like the ETL tool in it. So it's taking the logs and converting them into usually JSON arrays. Elasticsearch is a NoSQL database that kind of stores on anything very, very quick on the searches, and Kibana is a visualization that does all the graphs and all the cool stuff in it.
So essentially, there are 3 libraries, right? You have the Logstash, Kibana, and Elasticsearch. Anyone knows, let's say this is the basic, you install it and you can do your POC, you're pretty happy. You said, okay, it took me only 3-4 hours to do that, I'm really happy. Let's say I want to go production. That has to be a huge scale, but I want to go production. What should I do next? Any idea what will not work in software?
Logstash.
Why?
User. Because the load in the system probably will be higher.
Very good. So will be a load on the Logstash. Logstash is a JVM. It consumes tons of memory. You run it on the same box with Elasticsearch. It will break for sure if you send more than a few loads a minute. So yes, we'll get to that in a minute. I think if Logstash will also break in another direction, maybe this is also what you meant. If let's say that I have my shippers, the machine that ship data in here. So I placed a few agents, and now they're shipping data into Logstash. And let's say that Elasticsearch, it's a database, right? The database can be busy. And Logstash tries to push to Elasticsearch, and if we fail, Elasticsearch is busy. It's fully consuming the resources that it has in the box. What will happen is that Logstash will lose logs. We'll lose bulks of logs, and then when a developer or you guys will log into the box, you'll see only half the logs, right? You can go crazy by debugging when you have half the data. So the first thing you should do is put a Redis in front of Logstash. This is the buffer, right? Redis knows how to listen to incoming logs and just buffer it up until Logsearch will have the resources, say, okay, now Elasticsearch is not that easy. We can get logs from Redis and push them to Elasticsearch.
Presentation will be shared with us?
Yes, yes, don't write. Everything is already in SlideShare. I can send you a link. It's on there.
What does the aggregation of the data, the logs is a log,
Right.
Aggregations of the data, crunching, great for sure.
Good. So we'll get to that in a minute, right? So aggregation is done on Elasticsearch. Elasticsearch is a search engine that the aggregation gets all the data, indexes the data, and then you can say, okay, how many exceptions did I have in the last 24 hours of the last week, right? So we can have a complicated question, and Elasticsearch is the aggregate. Next thing is security, right? You want to make sure that you have a system. These logs can have like personal information. I want to make sure that I don't want to access it, not trivial. But the simplest solution would be to put an Nginx, like reverse proxy, on the front before the user. So you can, and essentially, this runs on the web server, so you can have access control to the web server. So you can say, okay, you know what? Only these two people can access the system, but you cannot really say, you know what? I want Jenny to be able to change stuff, and Tomer cannot change it. You don't have role-based access, you have basic authentication. There is no solution today to do role-based access to say who can access and see what site and what. Next thing you would probably want to do is delete all data from Elasticsearch. Elasticsearch is very, very sensitive to performance, to storage. The more emphasis it on, the more resources it needs to consume, and probably most people will hold data for a week, 2 weeks, a month. If you want to hold it more than that, you will have to assign a lot of resources for the Elasticsearch. So there's a tool. It's offered by the company Elasticsearch. It's called Curator. It's open source. It's free. You have to run it as a daemon. You have to make sure that you configure it well, but it effectively deletes the old data from Elasticsearch. So very, very useful. Very recommended. A question that we got from here was a comment about the Elasticsearch application failing. Probably when you want to start scaling beyond, I don't know, a couple of gigabytes of data a day, you want to have a cluster of Elasticsearch. Clustering Elasticsearch is a topic on its own. You can read a lot of data about that. I'll give you my sense. We have multiple clusters, 20 and 40 nodes of Elasticsearch. Is always have 3 master nodes. Master are the managers of the cluster. They are in charge of who's up and who's down. Why not 1? Why not 2? Why not 3? 2 because they will fight who's the master. And if you're going beyond 1, so you have to have 3. So there will be no competition. And at least 1 data node that will run the data. This already will be the infrastructure to scale Elasticsearch. Maybe we'll use Elasticsearch for just search, for application level. This is more a use case of how to use it for log management. It's a little different in the way you configure Elasticsearch, because in the log management scenario, you push a lot of data, but you don't search it often. You can search once in a minute, once in 2 minutes. In other use cases, you search a lot like a website search, so you have to configure Elasticsearch differently to fit the performance. So probably the default setting would work. I will touch on Elasticsearch configuration later on, but if you're running on AWS or Azure or any other cloud, the clustering will not work for Elasticsearch out of the box. Because Elasticsearch communicates between each node, it communicates via multicast, and that is not working on the cloud. You have to explain to Elasticsearch how to communicate over cloud. On Amazon, you have an AWS plugin, which is very recommended, it works very well. There are other problems with Amazon, but this problem is solved. On Azure, you will probably want to use Unicast and other solutions to cluster Elasticsearch. Questions? Good. Next, you will quickly figure out that Logstash pushes stuff to Elasticsearch, but I don't know the percentage. It depends on how you ship your loads, but 1 to 5% of your loads will not reach Elasticsearch. That's a huge number, and the reason is that you really need to understand how Elasticsearch works. Elasticsearch is a NoSQL database. it doesn't have a schema, or in Elastic they call it mapping. But when the first JSON arrives in Elastic, it automatically creates the schema for the mapping for it. So let's say that you're setting the timestamp, and then the error level would be like error 2. And then on the next log, another developer said, hey, 2 is not, I will use warning. It's better than a number, right? It's more usable. So Elastic will say, hey, 2 and a number, 2 and warning is not the same. It is a string, this is a number, or this is a number, a float, and this is an integer. So according to the first document, each log is called a document. According to the first document, it will implement the schema, the mapping. So you will see multiple logs are dropped because of wrong schema on the Elasticsearch.
The last record or the last
the first will be inserted into Elasticsearch, and it will set up a dynamics mapping. It will say, okay, this document is built out of string, timestamp, integer. If you send another log of the same type with the same field names, you say, okay, error number is, it's just a string now, or it was a float, now it's an integer. It will just print 1. And you will get an exception on the Elasticsearch. And that slows down the Elasticsearch significantly. So you would probably have to monitor these issues, go to the developers or whoever ships the log, and make sure they never change the schema, or they never change it on the fly between different times. This is one solution. The second is you can capture these and put them in a bucket, try to enter them later. We've done that work. We showed our architecture. It's not huge, but it has a whole. What we're doing is we try to fix them on the fly, we save them, and then we push them in stream. We do a lot of work to make sure that you get 100% of your logs. But if you do it on your own, just make sure you monitor that and make sure you don't have too many of these and your family is losing them. Questions? What else? So we said first, we mentioned before, you want to run on different machines, especially Elasticsearch and Logstash. Even if you are working in slow, in not huge scale, you want to separate into different instances. Just because the way Elasticsearch works, it will use all the machine, all the memory that is owned by the machine. And Logstash will also use all the memory. They are both very sensitive. So running them together, high quality system, if you don't have a scale, this will break, run them on different machines, and the next we run them on different machines. Well, it's not a must, but running stuff on top of Elasticsearch is always a bad habit, always a bad practice, always use different machines. Can this still break? Like if load management is important for your business, for your operations, what else should I do? Any idea in terms of availability? So I have these 3 servers. I'm happy. I have logs now. They're really saving me from congestion, and I'm really happy. And I have good scale. I want to make sure that if something fails in here, it will still work, right? I want to make sure I don't have a single point of failure. Let's say this Logstash breaks, and Logstash will break, I promise.
Load balancer?
Sorry.
Load balancer?
Yes, exactly. So you want to probably load balance the traffic between 2 availability zones in AWS worlds. So it doesn't have to be huge machines, but you want to build an infrastructure that scales because data has a tendency to pile up. They pile up really quickly. So we recommend even using smaller machine, but use 2 availability zones. We use all availability zones because for those who work on AWS, it does break. For us, it breaks all the time, and Amazon just turn off machines because they just feel like turning off machines. So just putting 2 of each at least on the data nodes, and then you have a good solid, because once you have a good clustering works really well for us. You can just drop this node and everything will continue to function. And it's pretty cool. So if you do that, you will have an awesome log management system in terms of ingestion, which is scalable, and then the whole pipeline will work very well. Be resilient to issues. The only small problem left is on the load balancing section. How do you divide the traffic? Using the ELB, for those who use it, it's probably not the best solution because it takes time to warm up. And once logs by nature are very aggressive, file was purged, and now it's pushing 2 gigabytes of data into Redis, but the load balancer in the middle will take time to warm up and will drop off most of the logs. So, and this is one problem. And the second problem with ELB is around UDP. Many of the loads are sent from devices which don't have TCP. So, and the load balancer cannot load balance UDP. Or we did a trick with using routing to actually route traffic and load balancer via DNS. It's working well.
Then the user accesses these two parallel systems.
The user accesses the Kibana. This is the front end
Yes.
via an ELB that takes it to the relevant.
But there are two separate systems here, two separate databases. Are the Elasticsearches clustered together in this scenario?
This is the same entity. Just highly available on two different levels.
Okay.
In the Redis and the Workstation, let's say that the Redis and the Apple are phase, and you use all the records that are in the Redis, or are they replicated to Redis?
It depends on how you define the Redis. Probably if you can define applications better. We're not internally using Redis, we're using Kafka. But if you use Kafka, so Kafka first it's you can replicate the data, but even if it drops, even if it fails, Kafka is persistent, but it's much more complicated to set up, and we have a larger infrastructure. But most people actually use Redis. I think in many cases you will have consistency of the load that's still sitting in the machine. So while you still have a service up, you can still play the loads and push to the pipeline.
Putting the Workstation, each machine that has a service, the bad practice because the Workstation tends to consume lots of memory crash. So
Yes. So this is a good point. This is a good
in
point.
the Redis and then
Exactly. That's a good point. Just to say it again. So if you have small machines, don't put Logstash on the machine that generate the logs, like the actual machine that do the work. You can use Logstash forwarder just to forward the log. This is lightweight. You can use RSys log. Windows use something else. But Logstash, if you want, many people do run Logstash on the endpoint itself, but make sure you have a strong machine because it will take at least a gigabyte of memory to process the logs and to pass the logs. This is one option. And second, use smaller like RSys log and pass the logs separately in.
Do you use an Xlog on the clients? Xlog.
Yeah, you can use that as well. Yeah. If you build this system on your own, it doesn't really matter, right? If the best way for the system to get is to get JSON. So machines can generate JSON. This is what Logstash does. It takes a line of one log and tokenizes it and converts it into JSON. This is the input for Elasticsearch. So the earlier you can generate JSON from the app, this is the best. From your Xlog, you can generate JSON.
it's best to have a schema for all JSON prepared, otherwise things will.
It's not easy to manage it because some developer just writes a new log, is new feature. I want to, oh my god, I have this error. Let me write the log. It's harder to have a fixed schema. You have to make sure the developers write JSON. If they generate JSON from their own code, make sure they use a central library. Make sure those are aligned and not overwriting the different types.
If I have few types of log in the same log,
What do you mean by few types of logs?
few types of log schema in the same log, few applications that with the same log. I need to how do I generalize it?
Yeah, I mean,
Something like the mega issues.
it's going to work fine. So one of the recommendation, if you're going to have a work overlap field, is to set the type field on the messenger. So if you go on JSON, say this is type Kafka, and this is other type, then it's just going to work fine.
Oh, okay.
So let me say on the log message itself, so type is like a reserved field in Elasticsearch, which corresponds to a specific table schema.
Once you define a type, you get like a new schema. Great. So we sort of the high-level architecture. Now let's talk about some tips that we can share. Grok is the term used by Logstash to parse the logs. Someone have ever wrote in Grok or used in Grok? Did you like it?
It's nice.
You liked it?
Yeah.
Okay, first one ever. Good. So
It has lots of out-of-the-box patterns that you can reuse.
sorry. Yeah, but it's not trivial. Be very careful when you write blocks. We have used source control to save them because they're very susceptible to a bad space or one character you got wrong. We're working now on an open source tool that we're able to visualize instead of writing code or configuration for block to visualize, look at the log and just mark, field and say, oh, this is an integer, this is a string, and then it will be converted into block. So hopefully we can help with that. We have some blogs about how to write good logs configuration, what's not to do. So we can help. So we mentioned AWS plugin. If you're running AWS if you're running Elasticsearch on AWS, one option would be to use ephemeral storage with the storage that comes with the boxes and the local disks are deleted when you stop the machine. Another option would be to use EBS. EBS is the remote storage. EBS is not, the latency is too high for Elasticsearch. It doesn't work very well. Maybe it works on a small scale, but once you scale it a bit up, it might cough and might not work. So from our experience, it's not working. We're working with different methods which are ephemeral storage with high redundancy rather than use the Amazon EBS. I would consider using that. And if you are using EBS, use provision IOS because Elasticsearch is very sensitive to IOS. It needs a lot of disk access. And that will run out of normal. There's a really cool configuration on Elasticsearch, which let's say that I want to have each log, each document replicated at least once. So I have one and another replication of that. You can tell Elasticsearch, listen, I want to make sure that if I have two nodes, the data will be replicated to two availability zones. It will enforce that the data will not sit only on one availability zone. This is a lifesaver. It's a really cool feature. You can do it even if you're not on AWS. You run your own data center. You can still say, okay, I want to have it in this room, that room, on that. We have a blog about how to configure that. It's very simple. Use the F3 snapshots to do backup. Elasticsearch will fail one day. Data is not that important, but for us it's super important. We do snapshot all the time, and like any database, it can get corrupted. So it's really cool. It was really easy. Same curator that's doing the deletion of all data can do S3.
Can you do snapshots on ephemeral storage?
Yes. So we're not. So you can. It doesn't matter what Elasticsearch is running. It's running on ephemeral storage. You can do snapshot. Take S3 bucket. Just copy.
Elasticsearch snapshots.
Yeah.
Elasticsearch.
Another reason to do the snapshot is because Kibana, which is the visualization, is saving all the configuration in Elasticsearch. If you're going to lose the data, regardless if you're going to lose the log messages, you're also going to lose everything you built. So it's a good idea to run a cluster and to back it up.
Actually, some of our customers didn't do it before they were our customers, and then this caused them to become our customers because they don't want to. They were hurt by that. So it's a good idea. Let's see what we do. We're doing it a little differently. This is a job for logs. So as I said, logs are coming into the pipeline. We're putting them into Route 53. Then they go to code rewrote, which are we call them listeners. They're the first entrance to our pipeline. Logs are coming into this. We've validated these logs are legal. They've been come from a legitimate customer. That they're not poison. All this security crap. Then they go into what we call a broker, a Kafka broker. Kafka is one of the best open source libraries we have used. It's super stable, super fast. It's like Redis, but it's persistent. And if you look at the performance metrics that we've done it with it as well. But Redis versus Kafka versus RabbitMQ, it's like 10 times faster. So we're super happy with Kafka. So once the logs get into this, is really lightweight, it's saved into Kafka, and then we have a promise that once it's here, it will never be lost. And here, it's so light that we're not losing anything anymore. So why it's never be lost? Because it's always persistent, it's always designed on this. But it's obviously you need to manage a cluster of these, and this is a little bit harder. Once it's on the Kafka, we have the time. Now we take our workers, these are log analyzers, this is how we call them. They take logs from Kafka, they're doing the processing, we're doing the business, we're passing the logs, we're validating all sort of stuff. We're running our, what I mentioned in the beginning, this ability to pinpoint the important logs. So some logs all logs will go through this filter of, this is the filter, this is the knowledge of the important logs in the world. We're running them inside the log analyzer, and we match them, and once a day we get a log which is super important for the customer, we know that, and we sort of mark and tag this log is super important. And then it will go into Elasticsearch. So we have clusters of Elasticsearch which are multi-tenant. So we have, every customer has a different index. Let's say you're a big company, you want to offer Elasticsearch to your customers, it's something you probably should do. So we have clusters that support multiple customers. Each customer sits in its own different isolated index. But Elasticsearch doesn't have out of the box the ability to say, okay, this log can only go to that customer. So we have built this sort of layer approach, these analyzers that implement multi-tenancy on Elasticsearch. We have also sort of indices manager because Elasticsearch, the performance of Elasticsearch is very, very sensitive to how the logs look like, how many queries we do. And we have developed technology around where to put each log, each index of the customer. Some customers are very noisy, some of them are new data with stronger machines. So we have a lot of logic around what to do with how to create indices on Elasticsearch. We'll continue from that side, and on top of that we have alerts. So it's something that doesn't exist in ELK, that we basically cross all the logs again against a filter of alerts, and user can find. I want to see, we have like security alert. If someone accesses our console from a place which is not Israel or USA, we want to get alerted about it. Okay, someone enters our Amazon account from a country we're not okay with that, or something, too many exceptions, or you can set up any alerts you want to set, and they will run on the ELK. On the front end, we have Play Server. This is a Google framework that serves the customer, and it serves Kibana. On the back end, we have a microservice architecture, so everything runs as a small service on a Docker by itself. So everything you saw is on Docker. All our continuous integration is Docker. Testing is on Docker. A developer can, on its Mac, run 12-layer Docker, so all the Docker will run on the Mac, and all the pipeline will run on the Mac for testing, for development. And obviously, everything is monitored by a different cluster of ELK. So we're using ELK intent very, very extensively to both monitor the forensics of the logs, but also do monitor, active monitoring, like numbers. We collect matrix, we collect D, collect L from all the machines, and we ship them as logs into the system and run queries and run analytics on top of them with ELK.
Sorry, what system are you using for alerts management?
Our internal system, we have part of the service, we have customers, we have an alert system. We have
There is no open source.
No. Any questions? So a quick demo.
Yeah.
Stuff.
So I think the big question is like, if you follow the Thomas presentation, okay, so I did all of it, so now what? What do I do with the data? Which is a question we get a lot. We have some of the data, data. So I just want to give you a few kind of use cases of how we use it and how a little bit insight into the insights that we've just released. So this is how Kibana looks like. I don't know if you're familiar with Kibana itself as a product, but so this is Kibana version 4. Naturally, it comes in white colors, but we decided that black is cooler, so we've kind of changed the skin on it. The previous version of Kibana 3, came in black, so we thought it's going to be a little bit more consistent for users migrating. So the basic thing you can do is search anything in your logs, and you can see this is a monitoring of some of one of our environments. You see that we're getting in the past 12 hours. This is a timestamp per 10 minutes, so we're getting about 5,000 logs per 10 minutes, sometimes even more than that. You can easily zoom in and see how the environment is performing and see all the different logs, click on them, see the separate messages, and just click on it and see what's going on in the log file. Everything we do, so when we push our own logs, we push them in JSON, but we also get logs from Nginx, we get logs from CloudTrail, we get logs from Kafka, we get logs from a lot of other systems, and like you asked, all of them is being put into one single Elasticsearch index, which we use a daily index for. So let me give you a couple of examples of things that we do. So one other way of navigating through this is, let's go back to store hours. One of the most important fields is called type. So you see here, so we have the types that we do here. This is because Elasticsearch, this query does not return all the types that are available, because Elasticsearch is only running it and getting like the first 5 or 6 results in it, and the first 5 results, and then that's what it's presented to you. But we know, for example, that we have CloudTrail in, so I can type in CloudTrail, and I can see the logs that are coming in from CloudTrail. I can open each one of them. For those who use AWS, CloudTrail is a mechanism to record all the events that are happening on the AWS environment. So the machine goes up, the machine goes down, someone changed the IP address, and someone defined another resource, another tag. Everything is being recorded using CloudTrail. It's being dumped into S3 bucket. So this is kind of like one example. You can see the user. This is one of our Devops people, Devops Israel, and you can see another thing here is, let's see, I want to see all the console events. So we have only 4 hours. So I can see all the times that anyone logged into our console, and I can interrogate it. I can see where they came from, and so I can see this one came from Israel. One of our guys, Zib, is another guy that works for us, and this one also is from Israel. One thing we need to, in our environment, we say, you know what, anyone who didn't come from Israel, and another way to navigate through it is click on the little minus signs here. So anyone who didn't come from Israel, I can just filter them out, and it's probably going to be no one, get an empty result, and what we do is we set an alert on it. So we want to know every time someone logs into our platform who's not from Israel, because we're all from here. So there is no reason for anyone to log into AWS who's not from here. So setting up an alert is simple. This is not a function of how the ELK, this is not a capability of the ELK itself. This is an additional thing that we've built. You can see the alert is being copied from the query line. So type CloudTrail and event name console login, and the country name is not Israel, that's why it's red. So I can type in Israel. I can type the description, and I want to check it. We can check it every hour, and I want to make sure that it's greater than or equal to 1. So even if a single time it happens, this is a high priority for us. Send an email, and we also have like a general email, and then we have to go with throttling it. So if you do a system that's throttling it, then you can set it up and say, you know what, don't enroll me in the next hour, the next 60 minutes, or something like that. So every time a search like that happens, and you can find it over time, you can say, I want these events to happen over an hour or 2 hours, and whatever time frame you want, you can set up an alert and you'll get alerted. I want to show you if you have any questions about what we do with this. So I want to show you a few dashboards that we're using. So this is a dashboard that we built for monitoring our systems. So this is an example of us upgrading our servers. So you can see these are two different servers. We switched to a new one. We use it to monitor and making sure that the performance is the same. Same thing here. This is one of our environments we monitor the Kafka lag. So we already also have an alert on the Kafka lag, but we do monitor and we want to make sure that the lag stays in a reasonable. If it grows, especially when we do an upgrade, obviously it grows because the Elasticsearch is being upgraded, but everything is being monitored. I want to show you, we've done a dashboard for CloudTrail. Obviously, security is very important for us, so we know where the events come from. So these are just generic events coming into the system. We know kind of like we want to audit like what type of events are happening, and we want to monitor. One thing key for us is the failed logins. So we want to make sure that this is, again, we have alerts on it that we don't get more than X failed login in a certain hours because it's a bad sign. We see the login, we see who's using it, we see security network and changes that have done to the CloudTrail, and we basically use it to monitor our system. The other thing, the other dashboard that we have is this is kind of a high-level view, which is we can see different events, so different creates. So create tags, run instances, which is basically creating another instance and running it, and so forth. And I think you see the Kibana itself and the Elasticsearch. First of all, it works very, very well, very fast, and it's very usable. So there's a lot of graphs and a lot of capabilities, both geographic, pie charts, line charts, area, everything that kind of like basically need to be able to visualize your environment. Another thing that we do, we also monitor our Nginx, that is kind of like setting up on front, same thing from here. I mean, we monitor response time, we monitor bytes, we monitor error messages, and again, we can see where people are coming from, what URLs, and stuff like that. So I think you've seen we had quite a lot of dashboards that we created, and we use it internally, obviously, to monitor and kind of get an oversight of our own system. Any specific question about Kibana?
Can I tackle it?
What? Yeah.
I think I saw there like a peak in the login time, the response time of the server.
Okay.
Can you just online try to find out the reason why?
Why there was a peak in response time?
Just
so this is just for this is not our production environment. This is a kind of monitoring part of our staging environment. You're talking about oh. So this you're talking about, or
I thought the last graph was the response time, but
The last time. What?
This one. This one. So this is obviously when we did the upgrade. So this is so you can see that. So in our environment, you can see this is the Kafka of the log engine, and this is the log receiver, the one that's parsing the log. So you can see that in that time frame, we have. This is an environment that we test stuff on. So someone was sending a lot of logs. So you can see it. A lot of logs correlates to an increase in the Kafka log, and then it goes down. So this is not a. You can see it by partition of things that happen. You can see the listener of all the incoming logs that we have. You can see that everything is like working harder at the time, but once everything goes down, then this goes down as well.
We have a table of the actual logs this time. So let's say you want to troubleshoot what happens, so you can suddenly mark the relevant time frame, let's say these 2 minutes, and then you can see the log you saw in the beginning. Discover you can have a table of these logs in here, and you can say, okay, let's see the error exception, what happened, what caused that. So it's very easy to
so I mean, you can see in this environment, for example, this is about 15 minutes, 14 minutes. We injected about 2.3, almost 2.4 billion logs into this, like 10 minutes. So test people are doing, so basically test the environment and how it's working. So this is why we have tough-band content to make sure that it expands on something like that. Because logs have the nature of when something bad happens, everybody's sending logs and there's a lot of messages, but then it goes down. And part of what Tomer didn't talk about on the architecture is that when you design it and run it yourself, you have to over-provision it because you don't want to be in a situation where you have a problem and all the system's sending a lot of logs, and then the log system fails. Because what do you need the log system if you can't like monitor the logs and you have a problem? So we usually see 8 to 9x provisioning. So if you're planning for 1 gig a day, usually setting up the environment for about 8 to 9 gigs a day from a capacity standpoint. So it's a good practice because both Elasticsearch and Logstash, once they can handle the load, it's game over. So it's not like they're buffered and they can crash. So so next thing I want to show you is kind of our insights, and this is kind of like what I was talking about with machine learning and stuff that we're doing. So the biggest question we found ourselves asking ourselves, like we have hundreds of thousands of logs coming in every second. What's important? Most of them mean nothing. Most of them is analytics, aggregation, stuff that is very interesting and we have visualization on, but how do I detect if there's actually a problem? So the way we do it, we kind of we leverage multiple sources on the internet and on our system to be able to extract information and crawl and build a database which is ranked by relevance. And we run all the logs through the relevance engines, and we mark in different colors things that we find is interesting in the log. So you can see, for example, this is running on the other environment. We have a staging environment. A few logs here are interesting. I can zoom in on them, and nothing. It's going to take a while to paint it, I guess. We did not put any data. So this is something which is interesting here. What happens when you run on stage?
You look at the logs.
But I can scroll down and see the relevant log. That's it.
Who wants to look at logs?
Oops, right. Okay, so you see the logs that are interesting for me to look at. We tag them with kind of saying these are Elasticsearch logs. You can open it up and we have some insights on it saying, okay, this is the Elasticsearch mapping exception. Again, this is a very important thing with Elasticsearch that happens when you can't insert the log because of the mapping issue. Other than not getting in the log in the system, it creates an enormous overload in the actual system. So it's a good thing to deal with it, and we have an insight to it. You can, link doesn't work, but you can link it and you can see kind of like things that people are talking about it. And this is all being kind of collected from what we have in what people are talking about and stuff like that. So this is kind of like our insight, and again, the goal is to be able to highlight the few logs that matter out of millions that don't. Questions?
So is this a service?
This is a service.
Or can you install it on your own infrastructure?
This is the whole thing is a service. This is if you follow Tomer's explanation, it's a pretty robust system. If you want to install it on your own infrastructure, it's a pretty big system to install. So just to kind of reiterate, we provide the Elasticsearch, the ELK complete stack, fully scalable, secure, highly available as a service. We provide additional feature like the alerting, like the role-based access, like anything that you would expect from a service that do not exist in Elasticsearch. And we provide the insights as a service on what we do.
You provide it on Google Cloud.
What do you mean? You can send
your
it.
system, or only
Right now we're running on AWS.
only?
Right now we're running on AWS.
But you can
We have customers
you
using
can from
yeah.
Azure, from Google Cloud. You have customers.
We have customers from Google Cloud that are sending shipping logs to us. It's a very efficient process, and we have customers on Azure and obviously on AWS as well.
How do all the additional metrics and analytics that you have put in place affect the throughput of ELK? In other words, how fast after log has been issued, you can see it in Kibana.
Usually so the other thing which we have in our monitoring system, which I didn't talk about, is that we inject logs every minute and we measure it. Usually it's 5 seconds, but we have an alerting if it goes about 40 seconds. So I would just expect something in that range to be appearing in Kibana. But a lot of it has to do also with the way you send log in your system. If you batch them up and send them together, it may take a few minutes, but this is a pretty quick process. And we have, I think what Tomer did, as complexity as it is, we didn't touch a lot of the issues about how do you spread indices among shards and how do you make sure that the system is optimized. And all of it is, we have engines that do that automatically. It's not a simple thing to do, but I think if you install the ELK basic, it's not a critical thing for you to do on stage 1. So I understand why you confuse you with that.
So,
More?
so you want to Tomer and Asaf?
We're here around, so if you have questions after that.
Applause. We have a couple of words from our hosts, Adnan.
Hi everyone, Elisha Bensky. I'm an engineering director here in Cloud Security Intelligence Group in CSI, as we call. This is all stuff that we're also dealing with. I was asked to actually stand right here next to the sign.
Yeah, just the cameras as well.
Oh, okay. So at CSI or here at Akamai, everyone knows what Akamai is about. More CDN is the traditional Akamai game area. But in the last 3 years, Akamai has penetrated the security area with a great force. In order to do that, what my team does is collect tons of information. And when I'm talking about tons in the Akamai scale, we're talking about something like 20 terabytes of logs per day that we need to process. And we were talking about finding the needle in a haystack. That we do that constantly on that amount of traffic. We have several infrastructure to do so. We do that all the time. We provided many applications and few specific products that are based on top of our infrastructure. Obviously, one of the major challenges here is scaling up, but also our challenges is the same as all DevOps organizations have. Continuous deployment, ability to do changes to the system while it's running, maintaining high availability, and all of that while keep on being hammered by this enormous amount of information. So all of this is done out here in Israel. We have 2 engineering teams, a DevOps team, obviously a QA team. We're hiring all the time, looking for talented people. We're actually hiring someone to the DevOps team to do our big data management. I call it BDA, not like DBA that was used to be, because it's all about the NoSQL. You need to turn the letters. And we're also hiring QA personnel and obviously engineers all the time. So if anyone wants, we have our HR representative here as well, and we're always welcoming good hires. That's it. Any questions for Akamai? And for that, we're actually starting to evaluate Elasticsearch as well. We build our own query engine because nothing actually scales to that amount, as you mentioned. Yeah. So no, Presto and Palo simply doesn't scale to those numbers. So we have to do practically almost everything by yourself. That's it.
Thank you very much. And we'll continue with Alex at 7:30. Okay, 10 minutes to freshen up. Or you want to continue right now? No? Sure.
Run away. זה מה שאומר, שני
עכשיו בן אדם שצריך שירות.
נכון, אבל מצד שני כאילו אומרים, מאוד בסוף, זה שלהם, וכל מיני משתמשים בזה. מצד שני אומרים, רגע, זה
של דבר, בסופו של דבר, כולם יש אותם
יש גם את הלוגים, מצד שני את המוניטורים,
קצת אמנות.
לא, זה כאילו של
Well, actually,
מסתכל בדשבורד, עכשיו נכנס בתוך האלסטיק סאץ'. Агрегация
No, just
אני הייתי בשביל יש פעם, אם יש נושא יש אם אתה הפס הראשון צריך לראות זה יוצאים, זה מערכת שתכלס מנחש.
Let's continue, please. You can bother the young people after they're staying tonight.
Maybe
Okay, let's start. First of all, I would like to ask, does anyone know what is Tessera at all? We heard about it. Okay. Let me introduce myself. My name is Alex Pekorovsky, and I work as a consultant in Devops Israel, and now I work on a big project inside Cisco, and basically Tessera is something that I implemented there, and it's using now, so it has a great feedback. So this also dashboards were created in Tessera. You can see that it can show a lot of different graph types, different skins, and all graphs can be configured with colors. And it may be not graph, but some metric, some value, or you can change time shifts, compare graphs, so on. So now I'm gonna ask 3 questions and try to answer them. So first of them, it's what is Tessera? Tessera is a front-end interface for graphite. By the way, does anyone know what is graphite? Who uses it in production? Yeah, great. So it's front-end interface of graphite. Also, it's a great way to build dashboards, as Tessera provides a large variety of presentations, layouts, and interactivity. In terms of Tessera, presentation means which type of graph will you use to display your data, because it supports different graphs and charts and tables, and honestly saying, I didn't understand all of that types. The second thing is layout. Layouts is basically positioning of the graphs on your page, so you can do it either from some structure or just from design point of view, how it looks right here. And interactivity, it's what you can do with these graphs. Like I already mentioned, you can change time shifts, you can compare data, you can compare to different graphs. So the next question is why is Tessera? Why not something else? Because there is a lot of front ends for graphite. So from my point of view, the main things, it's a separation of queries and presentations. When we speak about the separation, I mean that if we want to display the same data but in different formats, so we usually create 2 graphs and specify the same query to both of them. And later, if we want to modify it, we just modify it in 2 places. That's not really good. So Tessera created the way of separation. So you create query only once, you give some name to this query, and later in all graphs where you want to display it, you just select it by name. The next thing is transformation. In terms of Tessera, transformation, it's a method which accepts one dashboard item and return another dashboard item to replace it. So you can change your graph type without losing any data configurations, styles configuration, positioning. As I already said, graphs, charts, tables, a lot of different types, and you can extend it. Tessera supports plugins written in JavaScript. Basically, it's very new product, so it hasn't yet a lot of plugins, but it's in JavaScript, and it's not very hard to write JavaScript code. And of course, it's API. Really, does anyone wants to use anything without API nowadays? I think no. So, and the last question, what for we need it at all? Can we live without it, or which benefits it gives to us? First of all, it's a draw attention. For example, if you will create dashboards and place them in on hallway monitors, so people who are responsible for some metrics will see these metrics, and not only when they want to see. When they go to drink coffee, they will see monitor and see this data. So they might make some actions. I split metrics in three main categories, as I think. So it's engineering, developers, and sales. Engineering, it's basically stuff that we use to monitor with all different monitoring solutions like CPU, usage, memory, network, latency, I don't know, a lot of stuff. Developers metrics, it's, for example, how much time takes your unit testing, or how much time takes some blocks of code, your functions, and you can compare, for example, 2 weeks ago I had this function working 2 minutes or 2 seconds, and nowadays it works twice long. Why? It's because I added a lot of functionality, so it's like natural ways, more functionality, more time. Or it's something not related to amount of functionality and something should be fixed. So it's a point for developers to see what can be optimized. And sales part, it's let's imagine that you have a website that sells something. So for sales or marketing department, it might be interesting, like how many people are on your website now? How many of them really bought something? What is the average number of items that people buy? Or maybe some time frames when you have more sales and when you have less sales. So this information can give for sales or marketing some information like maybe to make discounts when you have less sales. So you can imagine any proposals of using it, but the main idea here is to draw attention. Requirements for Tessera, you see, it's not very hard, it's pretty easy. It's Python, which comes nowadays with most of the distributives, and graphite itself. So that's all you need. As I saw, some of you already know what is graphite. Some of you either just didn't want to say you know or don't know. So I will say a few words about graphite. You see how it looks like, and this is definitely not what you want to show on hallway monitors, because nobody will look on it. You can use this interface for debugging queries or to see did your data come to graphite system at all. So main function is store and render. All data is stored like metric name and value. That's all. And of course timestamp. The main difference to systems like Elasticsearch or simple databases like MySQL, it's that graphite aggregates old data. So, for example, if you want to display data that was 1 second ago or 2 seconds ago, you can do this. But if you want to separate data that was 1 year and 1 second ago and 1 year and 2 seconds ago, you can do this because it's aggregated and you can see like what you had 1 year ago. Because of this, you don't really use a lot of space and you don't need very powerful instances that can handle a lot of data because the older data it's more compressed in time. So what do we need for first launch of Tessera? First of all, I want to say that it has a great documentation and all first steps are described there. So basically what I want to say here, it's from the documentation. So Tessera is distributed using Bike or using Docker containers. And all you need to do is create a config file. In my case, it's config.py, but you can name it as you want. And specify graphite URL inside this file. Like graphite URL equals HTTP address to graphite URL. And then run Tessera with the environmental variable Tessera config. Like Tessera config equals pass to your config.py file. So, and you have Tessera working. One more thing that is not mentioned, it's access control allow origin header for graphite because Tessera makes all requests to graphite using jumps, and nowadays browsers are quite paranoidal and they doesn't allow you to do this request until you have this header on server. So just add this header to Nginx proxy before you graphite and everything will work. So the next our big part is configuration in web interface, and you will see that it's pretty easy, and you will see how Tessera looks from different points of view. So here is main page of Tessera. It's a list of dashboards. You can see here different dashboards. Each dashboard has its own category. So you see, in my case, it's physical machines and virtual machines. Each dashboard has tags, and you can filter by tags, like to display only dashboards that have tag ingest agent. In our case, 0, but whatever. Honestly saying, I used an idea from Sensu to mark each object with a chef role. So all these tags, it's basically chef roles in my environment. So I will try to guide you through the process of dashboard creation. We have here actions block and link new dashboard, and if we press it, we will see short form where we can fill title, categories, summary, description, and text, and not all fields are mandatory, so you can fill only, I don't know, title, and that's all. And you will receive such dashboard. It will be totally empty. It will include only your metadata that you insert. Here's how you configure queries. If you remember, I told that queries are separated from presentation views. So you write query and you name it somehow. I think if not of you heard about graphite and use it, you can't understand what's written here. But graphite has very strong functions that can aggregate or make some actions to your data. For example, in the first query, I take df means like disk usage, and like when you run df-h command on Linux, and this is percent bytes. It can be percent nodes, it can be not percent and absolute values. For me, it's in that case a lot better just to use percents. So I take from all hosts called which starts with IC build, you see asterisk, and I apply function highest max. So I want to take 5 highest values from all agents. Just an example. Graphite has a very long list of these functions, and you can read it. So I just called this query highest agent is, and later when I will configure presentation or graphs, you will see how I use these queries. So we will see how to do now. I decided not to do a lot of screenshots, so it's a video and I hope it will work. Yeah, great. So first we add section. In section, in each type, you have all styles configuration. So in section we add row. In row you will see the same styles configuration. Inside row we can create cell, and in cell it's a little bit more than in row styles configuration. You can add some like offset or width. I don't know why by default all your width it's 12, and by default width of one cell is 3. So setting it to 6, it's just like using half of your row width. So you can add, you see the list of different charts or graphs, and when you created adding some chart, you specify query, but by name, click apply, click, and the graph appears. So you can configure different colors for it, and titles, and high, widths, all the CSS stuff. I will create here just another cell with another query and another graph type. Let's wait until video finishes. So it's the same width, another graph type, standard time series, and another query. So you created dashboard with 2 graphs, and only you have to do is click save button, and you can share like this dashboard. It's not really very informative because I have dashboards with lots of graphs, but just as a sample, it's okay. So all you have seen here, basically it's in web interface. Web interface, it's a client for API. So everything happens in the web interface. It's really transferred to JSON in JavaScript, which runs in browser, and this JSON is sent to API. So how it looks like? You see our dashboard, and from this dashboard, something like this JSON is generated. So we have title category, I skipped all this metadata stuff, and after metadata comes definition. Definition is basically our layout. Definition has items. All items inside definition, it's items with item type section. Inside section we have items with item type row. In row we have items with item type cell, and inside cells we have graphs. So it's a very logical structure, and you can not. If if you decide that it's easier to configure this using some utility, so and not web interface, so you can do this because API is RESTful and it supports a lot of things like acronym CRUD. Maybe you heard it's create, read, update, delete. It's like main of operations, and of course you can do list of all dashboards. You can list text, categories, update them, delete them, whatever you want. So my first attempts to make dashboard creations automatic were successful with this long JSON. However, it looked not very good. Why? Because I had, I have now, like 300 servers, and I created a template per server to have ability to view CPU usage, memory usage, Java usage, and other stuff. But I created long JSON template and added it to Chef and send it to creation API. Very fast I understood that it creates every time when template is modified. So after some time, I had a lot of duplicates in Tessera. So I added delete before creation. It was okay, but I all the time URL changed of these dashboards, so I couldn't provide the ability to display them on the screen. So I started to implement some kind of logic. What should be updated, when it should be updated, how it should be updated, where to take templates, and this led me to separate project, which is now used too. So I will show you a picture just to you think that I'm gonna speak about DSL. So I think a lot of you heard DSL, but most of you think that DSL is something like ADSL, VDSL, it's internet that we use at our home, but not in this case. In this case, DSL stands for domain-specific language. Some of you might say that you haven't even solved domain-specific languages at all, but for example, SQL, it's a domain-specific language. So what examples? Chef recipe, it's a domain-specific language. So it's some kind of programming where you write what you want and not how you want. Basically, when we write some scripts, we write which operations we should do, like if statement, cycle. You write how, not what. And in DSL, you write what. So maybe someone was on previous meetup here when it was a presentation about Jenkins DSL plugin, and it was made by my colleague from Devops Israel and Meeetup. He's right there. So I decided to create DSL for Tessera, and I called this project Tessera DSL plugin. It is available on my GitHub page. I just get in time to move it to Devops Israel GitHub page. So what are the benefits? From my point of view, and as I can say that I'm greater fit, so it's easier to code. You write in Ruby language, not in JSON. JSON is really great format, but I think nobody can write 100 lines of JSON without any syntax error because of a lot of quotes, figure brackets, and other stuff. So on next slides, you will see how DSL code looks like in my case, and you will see that it's much easier. Next thing is idempotency. As I already said, it's I implemented logic. If do I need to make an update or nothing changed and I don't need to do this update. So it's not really about that you make a lot of the updates and your server will crash. But if you have, for example, 400 dashboards and because of one change in one dashboard in title of one dashboard, you need to make 400 requests. Why do we need this? The next thing is automatization. In my case, I just have in a Bamboo job that runs this plugin every 10 minutes and fetches templates from Git repository. And if there is updates, it updates dashboards. And of course, source control management benefits. You can have version control of this template. You can work in team. You can have a person to blame if nothing works. So how this DSL looks like. So you see, I tried to implement the same structure as it has JSON, but it's a little bit easier. You can just keep things that you don't want to specify. Like, for example, we can specify here category and can skip it if we don't want. My DSL plugin will automatically add all that stuff that we skipped just with null values. So it will be valid for Tessera, but you don't have to write. Of course, you can use as much rows inside sections or as much sections inside definition at all. You can combine, I know, any types of charts. All features that are supported by this DSL plugin are all features that supports Tessera in their API. So if they have something undocumented, so this DSL plugin doesn't support. So what can we do with this plugin? Assume we want to create dashboards for a list of hosts, and we want to create the same dashboards for different hosts. So you can do just simple cycle using Ruby, and you don't need to have like 10 JSON files and send 10 JSON files to API. So you just write something like this, and two dashboards in our case will be created or updated if they're already existing. For example, if you want to add search host to this template and use this template for search host, you just add here host 3 and run